Hello, Algebra 2 students. This is Ms. Prater. If you're in my honors Algebra 2 class, then this recording is replacing Thursday's Class Connect. We have been asked to cancel Class Connect on Thursday, November the 9th. We are having staff meetings that day, so teacher meetings that day. So if you're in honors Algebra 2, this recording is going to replace your Thursday, November the 9th Class Connect. If you're in regular Algebra 2, then this is going to replace your Class Connect on Monday, November the 13th. I will be out of the office on Monday and Tuesday, November the 13th and the 14th. So I'm kind of using this one video for two different classes. So anyway, this is 7.06 unit circle. This is something that I would consider brand new to you. I don't think you have a whole lot of background with the unit circle. If you've done some studying on your own for the ACT, you might have seen some problems with the unit circle. Since this is a video, I am going to go ahead and skip the do now and the would you rather just to save enough time. And y'all will excuse my voice because I have the crud. All right, for my honors class, if you're watching this video, these announcements go with the week that you're watching the video. This is the week of November the 6th through the 10th. Monday is 7:04, Tuesday 7:05, Wednesday 7:06, day 1, Thursday 7:06, day 2 with a quiz, Friday, Veterans Day, no school. If you're in my regular Algebra 2, then you're going to be watching this in place of Monday's Class Connect on November the 13th. And for your week, starting with November the 13th, regular Algebra 2, Monday is 7:07, Tuesday is 7:08, day 1, Wednesday is 7:08, day 2, Thursday is 7:09 with a bonus quiz, and Friday, November the 17th is a catch-up day. So just kind of follow along depending on which class that you are in. All right, you may remember, and I know I said earlier, some of this most of this is brand new material when we're talking specifically about the unit circle. There are tiny parts of the unit circle that you might remember from honors, from geometry. I don't know where that came from. You might remember special right triangles from geometry. So I thought I would bring this up really quick. So special right triangles are triangles that have the 30, the 60, and the 90 angles in them. That's one of the special right triangles. We also have the second special right triangle, which is the 45 degree angle and then the 90 degree. When we have these special right triangles, we have a specific ratio between the sides. So the angle that's opposite of the 30, or the side that's opposite of the 30, is called the short leg. And they give that value X. The side that's opposite of 60 is considered the long leg. And that value is going to be the length of your short leg times the square root of 3. And then your hypotenuse is always the side opposite of the right angle, and it's always 2 times X, or in other words, 2 times your short leg. There's always that relationship inside of a triangle that has a 30, 60, 90 degree angle in them. And the 45, I think it's a little bit easier. The two sides that are opposite of the 45 degree angle are called your legs, and they are congruent. So they're both going to have a value of X. And then your hypotenuse, which is the side opposite of the right angle, is going to be your short leg, your leg. There is no short leg or long leg in a 45 times the square root of 2. All right, so we do use those values when we're talking about our unit circle. So a lot of times when people see the unit circle on the ACT, they do think it's calculus, but it is not. So we have this circle. It's called a unit circle because if we calculate the radius, so if we go from the center of the circle all the way out to the right-hand side to a point on the circle, we get the ordered pair 1, 0. So this circle has a radius of 1 unit. 1 unit to the right, 1 unit up, 1 unit to the left, 1 unit down. So that's why it's called a unit circle. Inside this circle, I have a lot of angles, so let's just take a look. Our angles are going to travel against the clock, so we call that counterclockwise. We've got 30 degrees, 45 degrees, 60 degrees, and then 90 degrees. As we continue to rotate 120, 135, 150, 180. As we continue to go past 180, we get to 210, 225, 240, 270. And then continue on around 300, 315, 330, and 360. So we've heard about going all the way around, it being 360 degrees. We're actually going to use those larger angles for the first time in our unit circle. Now, the good thing about virtual school is I'm not going to make you memorize everything on this unit circle. If we were in brick and mortar, we would be studying this unit circle. You would have to label all the angles in degrees. These angles that have the pi in them, these are your radian measurements. So pi over 6 is the same as 30 degrees. Pi over 4 is the same as 45 degrees. Pi over 3 is the same as 60. Pi over 2 is the same as 90, and so forth. I would make you memorize the angles in degrees. I would make you memorize the angles in radians. And then I would also make you memorize these ordered pairs that show you how to go to the right and up to get to each point in the first quadrant, left and up to get to each point in the second quadrant, left and down to get to the points in the third, right and down to get to the points in the fourth. But since this is virtual school, you do not have to memorize everything on the unit circle, but you do have to know how to use the information. So let's look in the yellow box. Sine is always going to be the y value. So you're thinking about your ordered pairs. Here are the y values. So when they're asking you for the sine of 60, it's going to be square root of 3 over 2. When they ask you for the sine of 120, it's the y value at that ordered pair, square root of 3 over 20. Sine of 135 is the y value. So sine is always the y value. Cosine is always the x value. So if they said, what's the cosine at 30 degrees? You're going to use the x value. Cosine is x, sine is y. Tangent is the y value divided by the x value. Cosecant is going to be the inverse of sine. So always remember S is cosecant. It's CSC, abbreviated CSC. So it's going to be the inverse of sine. So it's going to be 1 over y. Secant is going to be the inverse of cosine, so it's going to be 1 over x. Cotangent is going to be the inverse of tangent, so instead of being y over x, it's going to be x over y. So let's take a look at these first problems. It says solve the following problems using the unit circle. So this says sine of 90 degrees. So we know that sine is y. So I go to 90, I find 90 is right here on my unit circle. Sine is the y value. So the sine at 90 degrees is 1. Number 2 says cosine at pi over 4. So I find pi over 4, it's here. Cosine is the x value. So that's going to be the first value in the ordered pair. So that's going to be square root of 2 over 2. Sine again is the y value. I've got to find 5 pi over 4. 5 pi over 4. I spent a lot of time looking for things. Here's 5 pi over 4. And they want to know the sine, so that's the y value. So that's going to be this value. That's negative square root of 2 over 2. Cosine again is the x value at 135. So we're going to find 135. It's here. They're wanting to know cosine, so that's the x value. So that's negative square root of 2 over 2. All right, let me double check my answers. I kind of flew through that. Cosine of 135. Yep, that's correct. So again, here you have to know sine is y, cosine is x. And we're talking about the x and the y of the ordered pair at the specific angle on the unit circle. So my personal opinion, those are not that difficult, the sine and the cosines. Tangent gets a little bit harder. All right, this says find the exact value of each function. We're pretty well doing the same thing. Number 5 is asking us for cosine, so we know that's our x value. So we've got to find 7 pi over 4. 7 pi over 4 is here. It's asking for cosine, so it's the x value. I'm not sure. I think I may have to write in white here. That's going to be square root of 2 over 2. Sine at negative 30. Okay, what do we do when the angle is negative? So let's remind ourselves sine is y. So we're looking for the y value. When the angle is negative, okay, when the angle is negative, we rotate clockwise. So to get to negative 30, okay, so positive 30 is rotating counterclockwise. So positive 30 would be here. So negative 30 would be rotating with the clock. And positive 330 would be the same exact angle as negative 30. So when you're rotating it with an angle that's negative, you actually rotate with the clock. So we're looking for the y value at negative 130, and that's going to be negative 1/2. All right, the negative angles are more difficult to me. My brain has to think a little bit more. Number 7 is asking us for sine, so that's the y value at the ordered pair, and then this time it's negative 2 pi over 3. So it helps me to look where the positive is in order to find the negative. So here's the positive 2 pi over 3. So it would be rotating, 90 and then another 30 to get to this positive 2 pi over 3. So since the angle's negative, I've got to rotate with the clock. So I've got to go to 90, and then I've got to go 30 more. So this would put me at negative 2 pi over 3. And they're asking me for sine. So that's the y value. And that would be negative square root of 3 over 2. So the negative angles, they kind of just go against my brain. So I have to really think about that. And it does help me to think about where the positive angle is. And then I just rotate clockwise to get to the negative angle. And if I haven't said this, and I don't think I have, when we're rotating, we always start on this positive x-axis. All rotation starts here. If we're rotating counterclockwise, the angle's positive. If we're rotating with the clock, the angle's negative, but we always start right here. All right. When the angle is bigger than 360 degrees. So I think these 3 examples are going to go with that. So one of the first things that I do is if I get an angle that's bigger than 360. So this is just one way to do it. But what I do is I take 360 and I subtract 360. So that's 1 revolution. So that just puts me back to where I started with. And this is going to make your angle smaller and easier to deal with. So anytime my angle is larger than 360, then I'm going to subtract 360 from it. All right, that's going to give me 240. So what I'm looking for is I'm looking for an angle that's between, okay, I'm looking for an angle that's between 0 and 360. So let's say this were 1,000 degrees and I subtracted 360. Well, that's going to give me an angle that's still not between 0 and 360, so I would subtract again. So if I had 1,000, I'd subtract 360, I get 640. 640 still not between 0 and 360, so I'd subtract 360 again, and that'd give me 280. I need an angle somewhere between 0 and 360 because that's going to be the angles that are on the unit circle. All right, so I'm at 240. 240 is between 0 and 360, so I'm going to find 240 on the unit circle. 240 is right here. They're asking me for cosine, which is the x value. So they're asking me for the x. So the answer to that one is negative 1/2. Number 9 is asking me for 9 pi over 2. The first thing that I'd probably do if they gave me the angle in radians with the pi, I would, if it's an improper fraction, I would turn 9 pi over 2 into a mixed number. So that'd be 4.5 pi. So if I'm given a radian that's larger than 360, so 360 is the same thing as 2 pi. So if I'm given a radian angle bigger than 2 pi, so that's the same as bigger than 360, but I'm using a radian measure, then I'm going to subtract 2 pi until I get an angle that's between 0 and 2 pi. So in other words, between 0 and 360. So if I do 4.5 pi minus 2 pi, that's going to give me 2.5 pi. That's still bigger than 2 pi, so I'm going to subtract 2 pi again. And that's going to give me 1/2 pi, or pi over 2. So pi over 2 is located right here. This is asking us for sine. So sine is the y value. So the y value at pi over 2 or 9 pi over 2 would be 1. I got a lot of writing here. Tangent at 7 pi. 7 pi is larger than 2 pi, so we're going to subtract 2 pi. That gives me 5 pi. 5 pi is still bigger than 2 pi. So I'm going to subtract 2 pi again. 3 pi is still bigger than 2 pi, so I'm going to subtract 2 pi again until I get a radian measure that's between 0 and 2 pi. And I can find 2 pi. I can find pi on the unit circle. And then they're asking me to find tangent. So tangent is y over x. So they're asking me to find tangent. Tangent is y over x. My y value is 0. My x value is -1. And 0 divided by -1 is 0. So let's do this. 1/2. -1/2 is the answer to number 8. I know I've got a lot of writing here. 1 is the answer to number 9. And 0 is the answer to number 10. All right, that was my main lesson. So hopefully that helped you just a little bit. So you're sticking with the thought of sine is your y value, cosine is your x value, tangent is y over x, cosecant is the inverse of sine, secant is the inverse of cosine, and cotangent is the inverse of tangent. There are a few you try problems here if you'd like to try those. I don't think I have the answers. So what I'll do is if you want to try these on your own and then just stop the video, you can. I'm going to go ahead and write the answers in. So again, if you want to stop your video and try these 4 on your own, and then once you've tried all 4, come back and I'll have the answers there for you. All right, if you turn the video back on, tangent at 5 pi over 4. Here's the order pair at 5 pi over 4, which is located, told you I always feel like I'm searching for stuff right here. And I've got a white pen. Y'all can't see that. So here's the ordered pair. And then we're going to divide the y by the x because they're asking us for tan. So negative square root of 2 over 2 divided by negative square root of 2 over 2. Those are the same values. So I'll always get a 1 there. Tangent at 180. Here's 180. Here's the ordered pair, negative 1, 0 at 180. Tangent again is y divided by x. That's going to be 0 divided by negative 1, which is 0. I'll do these last two kind of live so you can see what's going on. So we've got some negative angles here. If I find negative pi over 4, so here's positive pi over 4. So that would be rotating again against the clock to get a positive angle. To get a negative angle, we'd be traveling that same distance, but going this way. So negative pi over 4 would really be 7 pi over 4. They're asking us for sine here. Sine is the y value, so that'd be negative square root of 2 over 2. Number 4 is asking us for the cosine at negative 90. Again, this would be positive 90, so I rotate clockwise to get to negative 90, which would be the same as 270 degrees. They're asking me for cosine, which is the x value, and that's going to be 0. Hopefully this lesson was helpful. We're not doing the exit ticket since this is a videoed lesson, so don't worry about the exit ticket. If you have any questions, email me. So again, Honors Algebra 2, if you're watching this, I will be in the office on Thursday, November the 9th. They have just asked for us to cancel classes, so you can email me if you have any questions. And then regular Algebra 2, this video is for you for Monday, November the 13th. And I will be out of the office the 13th and the 14th, so you will get a reply that I'm out of the office